This video is on composition of functions and evaluating functions. Up top what I have is I color-coded 5 different functions: blue, red, green, pink, and orange. So the first 3 examples show evaluating functions, which we did in class, and then the next set of problems show how examples of how to do composition of functions, meaning we have one function inside of another function. Okay, so first one we have is f of 5. Now this refers to the function f of x. So like in class we said, whenever you're replacing x with a 5, you have to replace the other x with a 5. Okay, so I'm going to write out the function f of something equals 3 times something minus 4. Okay, so 5 gets substituted in for x, so make sure 5 gets substituted in for x. So instead of f of x, f of 5. So you evaluate, and you get f of 5 equals 11. And this can also be written as a coordinate. When you put 5 in for x, you get 11 back for a y value. So 5, 11 as well. Number 2, g of 3. So I'm going to write the g function, g of x. So g of something equals negative 4 times something plus 5. So wherever you see x, put parentheses. Now we're going to substitute 3 in for x. So put a 3 in wherever you see an x. Or in this case, our parentheses. So negative 12 plus 5. So g of 3 equals negative 7. So again, as a coordinate, when you substitute 3 in for x into the function, you get negative 7 back for a y value. Okay, number 3, a of negative 1. So again, I'll write the a function, a of something equals something cubed minus something squared plus 8 times something. So I'm going to substitute negative 1 in for r. So substitute negative 1 in for r. So negative 1 cubed minus negative 1 squared plus 8 times negative 1. Okay, so now I'm going to do these individually. These minus signs here I'm going to keep. This plus sign I'll keep. Just showing that you do each of the numbers individually between plus and minus. So negative 1 cubed is negative 1. Negative 1 squared is positive 1. And then 8 times negative 1 is negative 8. So this becomes negative 1 minus 1 plus negative 8, which is the same thing as minus 8. So you have, a of negative 1 equals negative 1, negative 2, negative 10. So a coordinate, substitute negative 1 in for r, and you get negative 10 as a value, or y in this case. Okay, number 4. Now these are done the exact same way. These are composition of functions. We have a function inside of a function. So to do these problems, you work your way from the inside out. So first what you're going to do is you're going to start with the innermost function. So in this case here, g of 7. So calculate g of 7 first. And then when you get the answer, you're going to substitute it in and become f of that number. So for example, I'll do g of 7, the inside. So negative 4 times 7 plus 5. So g of 7 equals negative 28 plus 5. Okay, so g of 7 equals negative 23. Now, since g of 7 equals negative 23, what I can do is I can substitute negative 23 in for g of 7. So in my original problem, instead of g of 7, I'm going to make this So instead of f of g of 7, this is going to become f of negative 25. Okay, because g of 7 is negative 25. We found that first. So f of negative 25 said f is 3 times something minus 4. Substitute negative 25 in for x. And we have negative 75 minus 4. So you get negative 79 for an answer. Okay, number 5, g of f of 7. The same thing. What we're going to do is we're going to find f of 7 first, and then substitute into the g function. So I want to find f of 7, substitute 7 in for x into the f function, and you get f of 7 equals 17. So now the original problem is g, and what we're substituting to the g function is f of 7, which is the same thing as substituting 17 in. Since f of 7 equals 17, do a substitution. So the g function is negative 4 times x plus 5. And we're going to substitute the 17 in for the x. So negative 4 times 17 is negative 68 plus 5. And you have negative 63 as a final answer. So the coordinate 7, comma, negative 63. Okay, number 6, f of 0. So what we're going to do is first find the answer, find f of 0. So substitute 0 in for x. So there's our f function. Substitute 0 for x. So you get f of 0 equals negative 4. Now f of 0 is negative 4, so our original problem, f of 0, I could rewrite it as f of, and since we know f of 0 is the same thing as negative 4, put negative 4 in for x. So the f function is 3 times something minus 4. And in this case, f of 0 was negative 4. So I have negative 12 minus 4, which will be negative 16. Okay, number 7, b of h of 1. So first I'm going to do is find h of 1 to the inside. So h is in green. So h of 1, so doing an inside function. First write out in parentheses wherever you see an x. So 2 times something cubed plus 3 times something squared minus 5 times something. So now substitute 1 in x. So order of operations. 2 times 1 to the third is 1. Plus 3 times 1 squared, 1, minus 5 times 1, 2 plus 3 minus 5. So h of 1 is going to equal 5 minus 5, 0. So that's what h of 1 equals. Now we're going to take the original problem, which is b of h of 1, and this turns into b of 0. And reason being, h of 1 equals 0, so replace h of 1 with 0. So the b function, b of something, equals 7 times something is 4 over 4 minus a number. So in this case, we're going to substitute 0 into the parentheses. So where we see the parentheses, substitute 0. And what you end up getting is 7 times 0 minus 4 over 4 minus 0, negative 4 over 4, which is negative 1 for answer. Okay, the next two problems have a composition of 3 functions. But again, looks harder and looks more intimidating, but it's really the same exact thing, except you have one more step to do. So number 8 is pronounced g of f of 2. G of f of 2. So again, you start with your innermost function. So we're going to find f of 2 first. So f of 2. So substitute 2 in for x into the f function. And you get 2. 6 minus 4. So now the problem reads, instead of g of f of 2, it's going to become g of 2. Reason being, I'm substituting 2 in for f of 2, since 2 equals f of 2. So now our next step, again working from inside out, is to find what g of 2 is. So g of 2, substitute 2 into the g function, and you get negative 8 plus 5, so g of 2 is negative 3. So this phase from above, I'm going to take what I left is g of 2, that was our problem, and it's going to become g of negative 3, because g of 2 equals negative 3, which is what we found here. Okay, so g of 3, negative 3, negative 4 times negative 3 plus 5, 12 plus 5, so your final answer is 17. Okay, number 9. It's pronounced g of f of h of 1. G of f of h of 1. So first thing we're going to do is we're going to do h of 1 first, so work from the inside out. So h is in green. So complete h of 1 first. And we already did that problem for number 7, but I'll write it out again. 2 times 1 cubed plus 3 times 1 squared minus 5 times 1. And what you end up getting is h of 1 equals 0. So now, instead of the problem being g of f of, oops, it's an f, of h of 1, instead of being this, replace h of 1 with 0. So now you can look at it and you're going to see, next thing you're going to find is f of 0. So f of 0, 3 times 0 minus 4, f of 0 is negative 4. So in the second phase, instead of having g of f of 0, it's going to become g of negative 4. Since, again, f of 0 is negative 4, substitute negative 4 in for f of 0. So now our problem is going to be g of negative 4. So you have negative 4 times x plus 5. Substitute negative 4 in. And you end up getting 16 plus 5, which is going to be 21.